Hi guys, welcome to my video. In this video, we're going to be covering compound inequalities. So the definition of compound inequalities is where two inequalities have combined together. And I'm just going to show you how we're going to be working out those scenarios. So let's get into it. If you haven't watched my video before, please go back and watch the introduction to inequalities, graphing, and finding the solution set. All right, so let's cover some basics. If you're given, remember from like video one, we said if you're given less and greater, remember these are not less or equal to, and these are not greater or equal to. They're simply less or greater. So what this means is if you're giving a solution set, you write with parentheses, and these are going to be these parentheses, right? And if you're drawing your dot where this starts, it's going to be an open dot, right? Something like this. Now, I want you to compare this. If you're given less or equal to, so this is less or equal to, and this is greater or equal to. Here we're going to be using square brackets like this, and the dot we're going to be using is going to be a full dot, right? And this is going to make sense when we start working out a few examples. If your solution set contains negative infinity like that, and then positive infinity like that, we're still going to use parentheses like this, right? So we're looking at our first example here, and it's negative 3x less or equal to negative 9, or you see this O? Yeah, there are two inequalities. Or 5 plus x is less than 6. Let me call this inequality number 1, right? And then this inequality number 2, right? Let's deal with inequality number 1 first. So it's telling us negative 3x is less or equal to negative 9. So we're going to divide both sides by this coefficient, really, which is negative 3. Guys, another thing I want you to notice, every time you divide an inequality by a negative, it changes the sign, right? So this cancels, and then you're going to have x is greater or equal to 3, right? So we have an x greater or equal to 3. Why is it changing to greater or equal to 3? Because we're dividing both sides of this inequality by a negative, and that changes the sign. So that is number 1. And then if we look at inequality number 2, it was 5 plus x, and this is less than 6. Remember, we are going to, the trick is you're going to distribute, collect like terms, and find the x value, right? So we need to take 5 the other side of the equation. We're going to end up with x less than 6 minus 5. You're going to get 1. So now let's plot these inequalities. We're having an x greater or equal to 3. So let me use green to plot this. So since we are having x greater or equal to 3, we're going to come to 3 here. We're going to use a full dot at 3, and anything greater or equal to 3 will be facing this side. Okay, so that is x greater or equal to 3. What about x less than 1? Since we're using less, we're going to use a dot that is not full, and I'm going to use red. Let me use red. So 1 is here, and it's going to be an open dot, and then a less is going to be this side, right? Please draw lines that are more straight. And then here we're going to write the notation, right? So the notation here would be x greater or equal to 3. This would be from 3, and then we're going to use square brackets because it's greater or equal to, and then comma. It reaches positive infinity, right? So then we're going to use these parentheses. And then here, because we're dealing with x less than 1, anything less than 1, it could be really 0. It could be negative 1,000. So the starting point is going to be negative infinity and then 1. But remember, because we're using less, we're going to use these parentheses. So to put them together, you would write square 3 infinity or negative infinity 1. All right, so this is going to be the interval notation of this compound inequalities, right? So that's the first example. So it's going to make sense, really. So this is just the first example. Please feel free to pause the video at any point, rewind it, or try out by yourself and see what you get. Let's look at example number 2. So we're still dealing with compound inequalities, and they're giving us two inequalities. 2x plus 9 is greater than 17, or right? You see that or 5x plus 10 is less than 10. So let's start with, let me call this inequality number 1 and call this inequality number 2. If we have, the first thing we're going to do is make x like the subject of this inequality, right? So we're having 2x plus 9 being greater than 4. So that is for inequality number 1. If we look at inequality number 2, they're giving us 5x plus 10 is less than 10, right? We end up with x less than 0. All right, so let's write the notation for 1, right? The notation for 1 will be any value of x greater than 4. So meaning 4 and then up to positive infinity. But remember, this is greater, so we're going to be using these parentheses. And then if we write the notation for inequality number 2, it's going to tell us any value. It could be negative 1000, right? Anything less than 0. So negative infinity, 0. And this is going to be the notation. So to write both notations, the interval notation, it will be for infinity, parenthesis, or negative infinity, 0, parenthesis. So that's the interval notation. But let's plot it now. I'm going to plot the inequality number 1 in blue because we're dealing with greater than 4. It's not greater or equal to, it's just greater than 4. So we're going to be using this open dot. So we just get to 4, draw an open dot, and it's anything here, really, that side, greater than 4. And then to plot this x less than 0, let me use green and just go to 0. I'm using an open dot still, and it's that side, right? So those are the two inequalities. This is the interval notation. This is how you plot it out, and this is how you work out these two inequalities. Thank you for watching, and stay tuned. See you in my next video.